Section 5.6, we continue with factoring. So far we introduced two methods. The very first method is you always look for common numbers or variable. The second method is group factoring when there are four terms and the first method does not apply. Then method number 3 is that how do you factor a trinomial? Okay, so I have x2 plus x minus 2. So the way to do it is we try to take the first number, which here coefficient is always 1 here. We don't see any number. And the last number, you multiply these two. So what do you have? 1 times minus 2 is minus 2. I need to find two numbers when you multiply these two numbers, it's negative 2. And when you add or subtract, it gives you positive 1. So what we do here, we look at all the numbers or coefficients here. So two numbers that when you multiply is negative 2, and when you add is positive 1. Okay? So what are those two numbers? It could be 2 and negative 1. Could be positive 2 and negative 1. Because when you multiply these two, it gives you negative 2, and when you subtract, it gives you 1. So now I'll open two parentheses. I put x in each. Why? Because x times x gives me x to the power of 2. Then I take these two numbers and put it in this parenthesis here. It doesn't matter which one you gotta put in the first one, which one second, it doesn't matter. All right, so that's how to factor trinomial. Now, to check to see if your solution is correct or not, factoring and multiplications are opposite of each other. So I'll just multiply this. X times x is x2 minus x, and I'll do this. See, you come up with the same function. So you know your answer is correct. I want to factor x2 plus 9x plus 18. Again, I need two numbers whose multiplication is 18. Since this is 1, we don't have to worry about that anymore. Two numbers whose multiplications, when you multiply, is positive 18. And when you add or subtract, it gives you 9 or positive 9. You know, sometimes if you want to find it, you could, use your calculator, and when you find this 18, go ahead and divide 18 by 2. See, that gives you the numbers, right? But maybe 2 and 9, when you multiply is 18, but when you add, it doesn't give you 9, okay? What about 3 and 6? 3 and 6, when you multiply is 18, when you add is 9. So here you open up two parentheses again, you put x and x, and 3 and 6. Okay. x2 plus 10x minus 24. Two number whose multiplication is negative 24, and when you add or subtract, it give you that. If I take 24 and divide by 2, it give me these two numbers, right? So then I need to work with this, 2 and 12. When you multiply is negative 24, and when you add is, so positive 2 minus 12 or -2, +12. Which one of these two pairs is correct? This one, because -2 plus 12, it gives you +10, see? So I'll put here -2 and +12. So you break these numbers, the third one, right? And try to find two numbers, so there's addition or subtraction, and give you the one in the middle. We need two numbers whose, when you multiply, it gives you -54, and when you add or subtract, it gives you +3. When I divide it by 2, it gives me 2 and 27. That these two would not give you +3. Let's break it again. What about 6 and 9? Look, you could work with this too, because 6 times 9. Now I need to have -54. So it's either -3, +9. I'm sorry, -6, +9, or +6, -9. Which one of these two pairs is correct? When you multiply, they both of them, when you multiply, give you -54. But which one of these two pairs give you +3? This one, -6 plus 9, give you +3, right? So again, you put x in each, -6 and +9. I want to factor this. Two numbers whose multiplication is 81. So if you want to break a number, always divide it by 2 first. If it doesn't work, then 3 and then 5. We normally take a number and divide by these 3, 2, 3, 5. Most numbers are breakable when you start with 2 first and then 3 and then 5, okay? 81, I use my calculator. 81 divided by 2, it doesn't work. 2 doesn't go to 81. But what about 3? I use my calculator. 81 divided by 3 is what? 27. See? Calculator would give it to you. 3 and 27. Now, I want the multiplication to be -81. So it's either -3, +27, or +3, -27. Which one of these two pairs give you -24? This one. See? When you +3 and -27, it gives you -24. So again, you open parentheses, -27 plus 3. Again, it doesn't matter whether you write x plus 3 or times x. In multiplications, positions of this parentheses are not important. Two numbers whose multiplication is -54. Okay, let's see, 54. If I take 54 and divide by 2, what does that give me? 27? But 2 times 27, it gave me 54, but not 15. Let's say 27 also is 3 times 9. So you got to play with these numbers. What about 6 times 6 and 9? 6 and 9. When you multiply, it has to be negative. So what about minus 6 and positive 9? But when you add, or when you subtract, it gives you positive 3, not 15. What about positive 6, negative 9? When you multiply, it's negative 54, but when you subtract, it's negative 3. So that doesn't work. Okay. What about 18 times 3? 18 and 3. See? You could play with these 3 numbers and come up with the one that works for you. Negative 18 and positive 3. Yes, these two. When you multiply, it's negative 54. When you subtract, it's 50. All right. So what we discussed were some kind of trinomial, and all of them did not have any number here. Number was 1. Okay? 1x2, 1x. That's why you could put x on each, because x times x will give you x2. Next, we discussed sum that has a number before x2 is not 1 anymore. See, in that case, I cannot open the parentheses and put x and x anymore, because x times x is x2. I have 5x2. But do I put 5x and x or 5x and x? I don't know. Okay. They have a special method to do this kind of trinomial. There are several ways, if you read the book, you might come up with a different way of doing it. But the way I feel is easier to understand is this. Take the first and the last number and multiply. 2 times 5 is 10. Okay? Find 2 numbers that when you multiply, it gives you positive 10, and when you add, it gives you positive 11, the middle one. So this one. Obviously, those two are 10 and n. 10 and 1. When you multiply, it gives you 10, and when you. So what do I do with this? Instead of 11x, okay, I write 10x plus 1x. Instead of 11x, I write 10x plus 1x. Why? Because now there are 4 terms, and I think of the group factor. 2 separate problems now. 5x, x plus 2, and if you recall, in the group factoring, when you find the parentheses, you don't have to worry about factoring the second one. You just take this, put it back here. And all I need to do is figure what I need to put here. That multiplied by x, give me 1x. Positive 1. So you have 5x plus 1, and the common parenthesis is this. See, if I take x plus 2 out, is 5x plus 1. Now, you want to check. It's a good idea to check a few times so you learn how to do it. Multiplications. Go ahead and distribute. You get 5x2 plus 10x plus x plus 2. See? That gives you the original equations. So that's a kind of trinomial that it does have a number here, but 1. It's not 1 anymore. Factor polynomial by grouping. Here you just say it. Factor the polynomial by grouping. So we are giving you a hint. Okay, again, take the first and the last number and multiply. You need two numbers that when you multiply, it gives you 12. And when you add or subtract, it gives you -7. -3 and -4. How about these two? When you multiply these two, it's +12. And when you add algebraically, -3 -4 is -7. So here, instead of -7x, you put -3x -4x, right? See? Because these two would give you -7x. By now, is a group factoring. I'll put x -1 here. Two numbers whose multiplication is, when you multiply, is -36. And when you add or subtract, it gives you +16. A minute you take 36 and divide by 2, it gives you those two numbers, 18 and 2. But I want to be -36. So is it -2 +18 or +2 -18? Both of them give you -36, but which one of these two pairs would give you +16? That one. So instead of 16x, you put 18x minus 2x minus 12, 3x plus 6. You put x plus 6 here. Is 3x minus 2 times x plus 6. (9x2 minus 17x minus 2). Two numbers whose multiplication is -18. And when you add or subtract, it gives you -17. Well, how about -18 and +1? This is easy. When you multiply, They give you minus 18, and when you subtract, it's minus 7. So instead of minus 17x here, you need to write minus 18x plus 1x minus 2. See, this would replace minus 17. Then, again, like the other one. Now, before you actually think of trinomial, when you want to factor a polynomial, always think of the first method first. What was the first method? Is there any number in common here? Before I actually think of group factoring, trinomial, all those, all three of them have 2 in common. So if I remove 2, see? Now you could factor this one. We need 2 numbers whose multiplication is negative 23, and when you subtract is negative 2. You cannot find those 2 numbers. Why not? Because 23 is the prime number. You cannot break it. Since you cannot break it, you cannot factor this part. So that's it. This is the factor, how to factor these functions. So not all the trinomial you're able to factor. Some of them, such as this, well, you did factor first, use the first method, but when you reach to this, you can't factor it anymore. So that's it. So don't be surprised when you have a prime number and you cannot break it. So if there is a prime, what is a prime? That you cannot break that number anymore. Like what? 11, 19, 23, 31. These are the prime numbers, okay? Because when you divide it, remember I said when you have a number, if you want to break it, always divide it by 2 first, then 3, and then 5. Most numbers are breakable when you divide by these. If there is a number that you keep dividing and it doesn't break, is the prime. See, this one, there are 3 terms, right? It looks like a trinomial, but remember, we have to always think of the first method. 80, 40, and 5, they all have 5 in common. They all have x. So then when you factor, what you have left is this. And there is a formula that if you have a minus b to power of 2 is equal to a2 minus 2ab plus b2. Means if you have the perfect square of the first one and the last one and twice of multiplications, then you could use this formula. See here, I have 4y2 power of 2 minus 8xz plus z2. So we could actually use that formula here. This problem is kind of different, okay? So we just threw that in the homework, but it's completely different with the other one because we rarely use this formula, okay? So that would be 5x times 4y2 minus z to power of 2. Okay, so that's the last problem of section 5.6.